So I spent a good part of my life building risk systems for banks, big banks, and you can see how it really helped them. And what actually came out of this was really a sense that just in general, we lack what I call risk thinking. We lack the tools that enable us to deal in everyday life with risk. So I want to give you lesson 101 in risk thinking. It starts with this. Risk occurs because there's a future, and that future is always uncertain. But just how uncertain it is actually really important. So for example, you can have various shades of randomness, things that are almost random, like on the left, or very random on the right. And I'm going to leave you with two words that I want you to take away. One is deterministic, in other words, almost known with certainty, and the other is stochastic, which means random. And these two words are going to play an important role in risk thinking. So let's take a good look at some examples. The statement, there will be a terrorist attack in India in the near future, is probably something you can say with certainty. So that's deterministic. When and where the next terrorist attack will occur is actually very uncertain, and that's stochastic. And the nature of the solutions you might use to deal with those two statements as problems differs tremendously. So for example, in a deterministic case, which is typically what management textbooks write about, you really need to know how to execute, hire the right people, do the right things, create the right supply chain. But in a world that's random, the optimal solution is to hedge. And just by knowing this fact, you can actually reverse engineer any decision or any solution that you might see to see whether it's appropriate. Let's take two airport security solutions. Well, on the left, you've seen a lot of. You've got grade 3 graduates given a set of rules, and those rules are going to catch the next terrorist. And on the right, you've got a different philosophy, which is, we don't really know where the next terrorist is going to come from, what they're going to look like, how it's going to happen. So we better psych them out as they come in the door with a PhD in psychology. So on the left, clearly, you're assuming that the world's deterministic, and with a bunch of rules, you can catch a terrorist. And on the right, you're assuming it's fundamentally stochastic, and so you better have some other solution. Let's take another example. It's 1991, gas costs $1 a gallon. And on the left, you're sitting in Tokyo at a board meeting, and in walks this kind of goofy engineer, and he's proposing this kind of goofy car called a Prius, saying, I think we should build this car, because there's a, possibility that we're going to need, really efficient cars. And on the right, there's this sort of team that in General Motors had a field day and built this wonderful little car. And there's a bored guy, with gray hair saying, let's kill it. And guess who killed the electric car? And guess how they solved this stochastic problem? Because at that time, you didn't really know. There was a real viable scenario that gas would be more expensive, that people would want electric cars, etc. And so Toyota took a hedge and put $1 billion down, and the upside of that hedge was they owned the hybrid car market. The downside would be, assuming hybrid cars weren't going to take off, they lost $1 billion, big deal. Let's take this to climate change. CO2 concentrations are high in the atmosphere. We know that. That's science. That's deterministic. But the effect that they'll have on us is stochastic. The first speaker actually brought this up. So we need hedges. We don't need solutions that are like the US security system. What's a hedge in this case? Don't build one type of renewable energy, build them all until you really figure it out. So we had a debate here at TED about nuclear or not nuclear. And let's take a look at that one. The solution for storing nuclear waste is typically not known today. There's some solutions that have been proposed, but it's not widely accepted that we have a solution. So we could think of that as stochastic. Now imagine the situation where you take a decision, no nuclear. And 30 years down the line, someone comes out with a fantastic solution for storing nuclear waste. Guess what you're going to feel? You're going to feel like the General Motors people feel with Toyota. Because in France today, all of nuclear waste for 1 year fits into a Volkswagen, and in the US today, you know, cutting down mountain after mountain after mountain to produce coal, to burn in the air, to produce mercury, etc., it's not a great alternative. So if you were to look at this from risk thinking point of view, you would say this isn't a debate about whether you should build nuclear, but how much you should do. And that's the stochastic solution. Now let's finally think about Katrina and George, two wonderful people. How should George have analyzed this problem? So it's 4 days to go. We can see that the cyclone is going to hit New Orleans, or very close to New Orleans. That's deterministic at that point. But what's not deterministic, what's stochastic, is the effect it will have. So what should he do? So if he sends in the National Guard and he's wrong, the downside is he spent a bit of money and he's made a couple of people unhappy. But if he doesn't send in the National Guard and he's wrong, he's got a huge problem, which is exactly what we experienced. So what would you do? Send in the Guard. It's really easy. So the bottom line is, learn to ask the correct questions. You know, is the data in this problem that you're looking at fundamentally stochastic or deterministic? If it's stochastic, then you should be hedging. And if it's deterministic, just get out one of those management books and go for it. And finally, before you choose, risk adjust, like George should have done. Thank you.